The story of the missile begins long before the age of computers and rockets. In fact, it starts with our earliest human ancestors. They needed to hunt and defend themselves from a safe distance. The simple act of throwing a rock was humanity's first step into projectile technology. Over thousands of years, this basic idea was refined. The thrown spear became a lethal weapon. It allowed a hunter to strike a large animal without getting too close to its dangerous claws or teeth. This was a massive leap forward. It fundamentally changed how humans interacted with their environment and each other. It was the birth of standoff warfare. These early weapons were all about human power. The strength of a person's arm determined how far and how fast a spear could travel. But brilliant innovations soon followed. The spear thrower, a device known as an atlatl, acted like a lever. It extended the thrower's arm, adding immense power and range to the projectile. This simple piece of wood or bone was a force multiplier. It allowed smaller individuals to throw with deadly force. Different cultures developed their own versions of these early missile systems. From the Roman pilum, a javelin designed to bend upon impact, to the slings used by ancient armies, the goal was always the same: to hit a target from a distance. The next great leap was the bow and arrow. This was a truly revolutionary invention. The bow stored energy in its limbs. When the string was released, it transferred that energy to the arrow with incredible efficiency. This was a much more powerful system than a human arm alone could ever be. Arrows could fly further, faster, and with greater accuracy than a thrown spear. This changed the face of the battlefield entirely. Massed formations of archers could rain down thousands of projectiles on an enemy force, breaking their charge before they even got close. The English longbowmen at the Battle of Agincourt in 1415 are a famous example of this power. The design of the arrow itself was a marvel of early engineering. It was a complete weapon system in miniature. It had a sharp point for penetration, a long shaft for stability, and fletching, feathers, at the back. The fletching was crucial. It acted like the fins on a modern rocket, creating drag that kept the arrow flying straight and true. Different arrowheads were developed for different purposes. Some were designed to pierce armor, while others were broad and designed to cause maximum damage. This ancient technology, the simple bow and arrow, dominated warfare for centuries. It was the pinnacle of missile technology before the world-changing invention of gunpowder. The invention of gunpowder in China around the 9th century changed everything. It was an explosive mixture that could create a powerful, expanding gas when ignited. This chemical energy was far greater than the mechanical energy stored in a bow. The first military use was in simple devices like fire lances, which were essentially tubes filled with gunpowder that could shoot flames. But soon, inventors realized that this explosive force could be used to hurl a projectile. This led to the creation of the first true guns and cannons. These were the direct ancestors of modern artillery, and in a way, the missile itself. They were loud, smoky, and terrifying. Cannons were initially crude and dangerous. They were often just large metal tubes, sometimes made of iron bars bound together like a barrel. They fired heavy stone or iron balls. These early cannons were not very accurate. They were slow to load and prone to exploding, sometimes killing their own crews. Despite these flaws, their power was undeniable. A single cannonball could smash through the stone walls of a castle. For centuries, castles had been the ultimate defensive structures, but the age of gunpowder made them obsolete almost overnight. The Siege of Constantinople in 1453 famously demonstrated this, where massive Ottoman cannons battered the city's ancient walls into rubble. The technology slowly improved over the next few hundred years. Cannons became more reliable and more mobile. They were cast from bronze or iron into single, stronger pieces. The science of ballistics, the study of how projectiles fly through the air, began to develop. Gunners learned how to aim their weapons more effectively. They calculated the right angle and amount of gunpowder needed to hit a distant target. This shift represented a move from brute force to a more calculated, scientific approach to warfare. The cannon was no longer just a wall breaker, it became a key part of battlefield tactics, able to destroy enemy formations from afar. This era laid the essential groundwork for what was to come. The basic principle of a missile is to use a powerful force to propel an object towards a target. Gunpowder provided that force in a compact, chemical form. The cannon was, in essence, a launch tube. The cannonball was the unguided projectile. While it lacked any internal guidance system, the cannon established the fundamental concept. It proved that chemical propulsion could be used to deliver a payload over a great distance. This principle would be taken to the next level with the development of the first military rockets. The age of gunpowder had set the stage for a new kind of weapon. While cannons dominated European battlefields, another form of gunpowder weapon was being developed in Asia, the rocket. A rocket is different from a cannonball. Instead of being launched by a single massive explosion, a rocket carries its own fuel. It is propelled by a continuous burn, pushing itself forward through the air. Early rockets were simple tubes, often made of bamboo, packed with gunpowder. They were attached to a long stick for stability. These early weapons were wildly inaccurate. They were used more to frighten the enemy than to cause precise damage. They would spin and tumble through the air, creating noise, smoke, and fire. The use of rockets in warfare spread. In India, the Kingdom of Mysore developed a particularly effective rocket in the late 18th century. These were known as Mysorean rockets. Unlike the earlier bamboo versions, they had iron tubes. This allowed them to hold more gunpowder and create more thrust. They could travel for over a kilometer. The British colonial forces fighting in India were terrified by these weapons. They saw firsthand how a barrage of hundreds of rockets could disorganize their disciplined troops. The noise and fire were enough to panic both soldiers and their horses, breaking up formations and causing chaos on the battlefield. A British Army officer named William Congreve was impressed by the Mysorean rockets. He decided to improve upon the design. He took the idea back to Britain and began his own experiments. The result was the Congreve rocket. These rockets were standardized and mass-produced. They were used by the British Army and Navy throughout the Napoleonic Wars. They were famously used during the bombardment of Fort McHenry in Baltimore in 1814. This event inspired Francis Scott Key to write the words, "The rocket's red glare in the American national anthem, the Star-Spangled Banner." These rockets were still unguided, but they were a powerful psychological weapon. The Congreve rocket and its successors represented the peak of unguided missile technology for their time. They were essentially flying artillery. They could deliver an explosive or incendiary payload over a longer range than many cannons of the day. However, their lack of accuracy was still their biggest problem. They were best used against large targets, like a city or a dense formation of troops. As artillery technology improved, with rifled barrels making cannons far more accurate, the military rocket fell out of favor for a time. But the idea of a self-propelled weapon had been firmly planted. It was just waiting for the technology that could finally steer it in flight. The 20th century, with its two world wars, saw an explosion in technological development. The dream of a projectile that could be guided to its target finally started to become a reality. The Germans led the way during the Second World War. They were desperate for new weapons to turn the tide of the conflict. Their engineers developed two groundbreaking missile systems. The first was the V-1 flying bomb. It was essentially an early cruise missile. It was powered by a simple pulse jet engine, which gave it a distinctive buzzing sound, earning it the nickname Doodlebug. It flew in a straight line towards its target, usually London. The V-1 was a terrifying weapon, but it was still relatively crude. It used a simple autopilot system of gyroscopes to keep it level and on course. A small propeller on its nose would measure the distance it had traveled. When it reached the target area, the engine would cut out and the bomb would fall to the ground. It was not precise, but it was a weapon of mass terror. The second German innovation was far more advanced. This was the V-2 rocket. It was the world's first long-range ballistic missile. It was a massive, liquid-fueled rocket that could travel faster than the speed of sound, making it impossible to intercept. The V-2 was a true game-changer. It climbed to the edge of space before falling down on its target at supersonic speeds. It had a more sophisticated guidance system than the V-1, using internal gyroscopes and accelerometers to control its trajectory during the powered flight phase. Once its engine cut out, it was simply following a ballistic path, like a thrown stone. It was still not pinpoint accurate, but it was a quantum leap in technology. After the war, both the United States and the Soviet Union scrambled to capture German rocket scientists and technology. This effectively kick-started the Cold War arms race and the space race. The V-2 showed what was possible. The next logical step was to create a missile that could be actively guided all the way to its target. This led to the development of various guidance systems. Some early anti-aircraft missiles used a method called beam riding, where the missile would follow a radar beam pointed at the enemy aircraft. Others used radio commands, with an operator on the ground steering the missile with a joystick. During the Vietnam War, the first laser-guided bombs were used. An aircraft would shine a laser on a target, and the bomb would have a seeker in its nose that would home in on the reflected laser light, striking with incredible accuracy. The late 20th and early 21st centuries have been defined by the information revolution. Computers, GPS, and advanced sensors have transformed missiles from blunt instruments into surgical tools of warfare. The crude guidance systems of the Cold War have been replaced by incredibly sophisticated technology. Modern cruise missiles like the American Tomahawk are a perfect example. They can be launched from a ship or submarine hundreds of miles away. They fly low to the ground, using terrain-following radar to stay hidden from enemy defenses. They navigate using a combination of GPS and an internal mapping system called TERCOM. This level of intelligence allows missiles to perform complex missions. A Tomahawk missile can be programmed with a flight path that has multiple twists and turns to avoid known threats. It can fly to a specific coordinate and then loiter in the area, waiting for the command to strike a target. This gives commanders on the ground immense flexibility. The missile's internal map is so precise that it can navigate by recognizing specific hills and valleys. This means that even if an enemy jams its GPS signal, the missile can still find its way to the target with pinpoint accuracy. The era of just pointing and shooting is long gone. Today's missiles use an amazing array of guidance technologies. Heat-seeking missiles, used by fighter jets, have infrared sensors that can lock onto the hot exhaust of an enemy aircraft's engine. Anti-radiation missiles are designed to hunt for enemy radar installations, homing in on the radio signals they emit. The development of advanced imaging seekers allows some missiles to see the target. They can be programmed to recognize the shape of a specific tank or ship. This fire-and-forget capability means the pilot who launched the missile can turn away immediately, without having to guide it to the target. The evolution of the missile, from a thrown spear to a smart weapon, is a story of human ingenuity. These weapons have fundamentally shaped global politics and the nature of conflict. They provide nations with the ability to project power across vast distances with incredible precision. This can act as a deterrent, preventing large-scale wars between major powers. However, it also means that conflict can be initiated from a very safe distance. The story of the missile is far from over. As technology continues to advance with artificial intelligence and hypersonic speeds, the missiles of the future will be even faster, smarter, and more capable than the incredible weapons we see today.